This introductory course is wrapped up by examining a few case studies on oil shores where SCAT was applied. It is an opportunity to reinforce many of the SCAT aspects examined. For comparison purposes, 3 case studies range from a catastrophic one, a heavy oil spill offshore, to a marine diesel spill in protected coastal waters. This module takes about 40 minutes to complete.
We're going to look at 3 case studies. One is the Prestige oil tanker incident of November 2002 in Galicia, Spain. The Westwood Annette was a freighter with its bunker C spill in August 2006 in Squamish, British Columbia, Canada. And lastly, the Queen of the North Ferry marine diesel spill in March 2006 in the central coast of British Columbia, Canada. Here's a synopsis of these marine casualties that resulted in an oil spill. First is the Prestige. It was an oil tanker. It was a catastrophic loss of the tanker. It actually broke in half and sank in the Atlantic Ocean. It was carrying a very heavy residual oil that extensively emulsified as it was in sea conditions, and there was widespread oiling of shores. Much of the oil hung around within the shore zone as transitional oil before it stranded on shore. The Westwood Annette incident was much more localized. When leaving a terminal, it struck a pylon, releasing its day tank of bunker C oil. The main impact was confined near the terminal and an estuary marsh. It was a protected area of the Howe Sounds and the Squamish River estuary. A key feature was that the impact area was inundated with high glacial silt originating from the river. The third incident was the Queen of the North Ferry that did a hard grounding on Gill Island due to navigational error. It promptly sank, and its bunker tanks that were ruptured released marine diesel oil. This was protected or semi-protected waters, and it was a moderate size of contamination. As the spill material was diesel, there was no shoreline cleanup undertaken. It evaporated very fast. SCAT area reconnaissance and shoreline sampling was still conducted. The Prestige oil tanker casualty off Spanish coast in 2002 is a worst-case spill incident owing to the amount of oil released, its type, and its spread and weathering. It became highly emulsified as it lingered out in sea for several weeks. This is when oil and water mixes and makes it very thick and viscous, and therefore difficult to recover. The Prestige was experiencing structural failure, but a place of refuge was refused, so it was towed out to sea, where it eventually broke apart and sank. Its cargo, referred to as fuel number 2, is a residual oil left after crude oil has been refined, essentially a sludge used in industrial boilers such as pulp mills and factories. It's classified as a heavy oil. Heavy oils won't disappear very fast, such as by evaporation and other means of weathering. This video of residual heavy oil spilled from the Prestige tanker gives a good depiction of how initially fluid oil becomes almost gum-like in consistency as it weathers over several weeks in ocean temperate waters, in this case the Atlantic Ocean. Open water recovery of the oil, even with very large offshore vessels, was slow. Most of the oil was recovered near shore or within the shore zone, as it became trapped and lingered. This is the transitional phase. Recovery was done by fleets of small vessels of opportunity, by people just scooping up the oil with rakes and shovels and modified equipment. At times, workers on shore would reach into the water and pick up this mobile oil as well. Both are messy and unsafe practices. Worldwide, the tactics to recover transitional oil near shore or within the shore zone hasn't changed that much. As for the oil stranded on shore, observe that the heavily emulsified oil with its water content doesn't penetrate into wet sand very far and is quite easy to remove. From a SCAT perspective, it shows the importance of knowing the fate and behavior of a spilled oil in the receiving environment, both offshore, near shore, and onshore. The top left video shows an indication of how oil becomes a bathtub ring along a coastline. Tides and splashing waves cause this distribution, but the main contributing factor is that oil generally doesn't stick to wet substrates. This transition oil is about to strand on shore. It can be observed by helicopter during field surveys, and because it's not going anywhere, it could be linked to shoreline units, and therefore part of a shoreline protection program and a SCAT undertaking. Insofar as having tactical equipment that is safe and effective, this is still the inexpensive oil to recover and not cause additional environmental impacts compared to if it should strand on shore. The overfilling of collection buckets is not the best practices as it spreads oil contamination from the oiled shore. SCAT can play a major role in oily waste minimization. It can reduce operational impacts by determining where to stage the collected oil. It is not a SCAT role to challenge poor practices or tactics of operations directly to them. Instead, raise the issue with environmental unit leader and planning section chief to address according to the incident command system's chain of command. You can take some pictures though to make your case. The image on the right shows how emulsified some oils can become, almost bread dough in consistency. This oil was peeled off wet rocks by 2 workers. It is not unusual for stranded oil baking in the sun to become tar-like as its volatiles evaporate. This applies to both crude and residual oils. A changing oil's physical and chemical properties is referred to as weathering. The more oil weathers, the more problematic it is to recover. An example is when fresh oil penetrates into sand or mixed sediments such as a gravel and then weathers. It creates an asphalt layer that's very difficult to remove. It's referred to as an asphalt pavement. The advanced SCAT training focus on where oil resides, such as the supertidal zone or where it's in the upper or middle tidal zones. Its oil distribution, whether it's continuous, broken, patchy, sporadic, or trace. Its thickness, whether it's pooled, or it's a cover or coat or stain. And its surface description, whether it's fresh or emulsified or otherwise known as mousse, whether it's a surface oil residue or an asphalt pavement. These are all standard SCAT field observation terms that you need to know and recognize in the field. This is advanced SCAT training and therefore not part of this introductory course. Going back to these images, the top center picture is showing a surface oil residue in the intertidal zone as continuous distribution. The upper right picture is showing an oil coat in the supertidal zone, also known as the splash zone, with a patchy oil distribution. The bottom picture is a oil distribution that's continuous and is a cover. The middle bottom is a typical bathtub ring showing continuous distribution. All this information is documented on a shoreline oil summary form, mapped and measured, and photographed by the SCAT field team. Field documentation of oil conditions is again an advanced level of SCAT training. These 2 images show the range of challenges for the Prestige oil spill. Oil over sand, wet shores are relatively easy to clean manually, insofar as the oil hasn't been covered by the sand, whereas marshlands are more sensitive, not to the oil per se, but to the operational responders trampling over it. For emulsified oil on sand, it's a simple case of using a flat shovel to scoop and scrape it off, whereas in the old marsh, you might undertake no activity or to burn it, insofar as the vegetation's roots can be protected by a water interface in the substrate. There are some 55 different treatment measures that could be applied to an oil spill, depending on the type of oil and receiving environments. Knowing their treatment measures, where they'll be applied, how they'll be applied, and feasibility is all part of advanced SCAT training. The Westwood Annette incident in British Columbia, Canada was a loss of its system fuel, known as bunker C. The loss of bunker oil from collisions, groundings are much more common worldwide compared to oil tankers and their loss of cargo. The Westwood Annette's fuel was much less viscous than that of the Prestige oil spill. The impact area is much smaller, with most of the product confined around the terminal and in a marshed area. The spill amount was much smaller. There was little time and opportunity for it to weather, such as emulsification. Since the transition from coal to oil a century ago, most seagoing vessels to operate their system and engines use a product generally classified as a heavy fuel oil. It's a residual oil as a result of the refining of crude oil. This heavy fuel oil is referred to by several names, either as bunker C, number 6 oil, or as an intermediate fuel oil. There's another new type of oil on the international scene. These are called ultra-low or very low sulfur oils. These are competent oils designed to meet air quality standards. Their fate and behavior is somewhat unknown. From a SCAT knowledge standpoint, it's important to know what type of oil has been spilled in its composition and weathering behavior. There's also health and safety considerations. As the image shows, regardless of what the name of the oil is, its viscosity is around that of molasses. It will float, and there will be a tendency when it's fresh to penetrate into coarse sediments such as pebble, cobble, and some gravels, but less so in sands and silts. There would be no penetration in bedrock. Heavy fuel oil still has a volatile component, so when stranded on shore, that component will evaporate and the product will become very viscous, almost tar-like over time. The location of the Westwood Annette bunker oil spill has a variety of interesting factors, such as it was an industrial site, it was a marine terminal, but it was near sensitive marshlands important for birds and other wildlife. It was at the mouth of a major mountain glacial stream with high sediment loading, and it was ahead of a long fjord. These factors resulted in SCAT decisions on treatments being quite variable. Though the old shores were very much in close proximity to each other, the decisions ranged from doing nothing to aggressive treatments. We'll take a look at these more closely. As shown by these two images, for showing oiling distribution from the Westwood Annette bunker oil spill, the color coding of the level of oiling of shorelines is very much of the SCAT process and is done in a very defined way. The information comes from SCAT field assessments and from the shoreline oil summary forms that are prepared for each segment assessed. The mapped representation of oiling conditions for the Westwood Annette spill guides planning, operations, and command to determine where the most shoreline work needs to be done. It was the oiling of vegetated marshlands that posed the most challenge to ensure a net environmental benefit. That is, not to cause more harm from operations than the oil itself. The image on the right shows that a ravine captured most of the oil during a high tide event. This bulk oil was removed by a vacuum system, which in itself did not cause much harm. However, the workers that were working around the edges of the ravine caused quite a bit of impact by trampling the marsh grasses. The image to the left shows that the grasses act much like an absorbent and amassed a lot of oil, but the wet clays in the intertidal zone did not. You can see rivulets of fresh mobile oil in the intertidal zone. At the very top of the image, you could see some oiling of intertidal zone, which was near the terminal and the vessel itself. The shore segment in front of the terminal was a gravel sediment that had moderate penetration of the oil. Many parts of the Squamish River estuary marsh was heavily oiled to a saturation level. The image to the left shows oil-contaminated marsh grasses that occurred during high tides. The ravine in the middle collected most of the bulk oil. In the intertidal zone, the oil clinged to some seaweed, such as this rockweed. It's the oiled marsh grass that's problematic. The estuary has a high bird population, and this oil would be a potential contaminant to them. Fresh oil on the surface of seaweed and the wet sediment tend to self-clean with tidal action. From a SCAT perspective, the intertidal zone and the marsh grass are two fundamentally different worlds to assess for treatment recommendations. For the Westwood Annette bunker oil spill, the type of management strategies used was very diverse, based on SCAT field assessments and shoreline treatment recommendations, as well as shoreline inspection reports. The 4 recommendations and treatments can be summarized as follows. First was the removal of transitional mobile oil trapped within a ravine. Second was the removal of heavily saturated marsh grasses by cutting and raking that resided mostly around the ravine. Then leaving most of the less lightly oiled marsh grasses for natural recovery. Within the oiled gravel sediments near the terminal and the source of the spill, undertake both wet and dry oil sediment mixing and recovering any of the bulk oil with pom-pom sorbents. These are actually quite complex SCAT decisions to make, so we're going to explore them a little bit more fully. For the Westwood Annette bunker oil spill, a ravine going through the middle of the marsh gathered most of the mobile oil and was removed by vacuum and suction trucks. Then the oiled grass removed manually by weed cutter and bagging for removal to a waste site. As such, the ravine had extensive operational activity in and around it. This required a large workforce that had to have access and egress to this location. The image to the left shows extensive oiling of marsh grass. Some of this oiling never reached the actual substrate, just the top 2/3 of the grass stems themselves. As this was an important bird habitat, the yellow ribbons were there to scare birds away from the oiled area. A significant impact to the Squamish River estuary marshlands was actually operational activities, not the oil itself. The workforce pathway to access the oil-filled ravine over the marshlands and choosing to manually cut and bag the oil-saturated vegetation was largely done before the SCAT program was fully implemented. There were ecological impacts as a result of this that did not lead to a net environmental benefit. This is an example of operations self-directing before SCAT actually gets engaged and ahead of operations. The silver lining in the Westwood Annette incident was a high glacial silt from the nearby Squamish River that flowed over the oiled grass during a series of high tide events. This silt-laden water stripped the oil from the grasses in a matter of a few days and weeks. Natural recovery or attenuation is doing a good job here. The image on the left shows the top part of the grass starting to have the oil removed, as shown by a gray area. Also observe that the oil never penetrated into the substrate itself. An important aspect of SCAT is to look for a silver lining in natural recovery and to communicate it to representatives and stakeholders to provide confidence that there will be natural healing such as this. Post-monitoring of the marsh a year later showed not treating even saturated oiled vegetation was the best course of action, as shown by the image to the left. where a workforce cut, raked, and removed oiled marsh vegetation resulted in operational damage to the marine grass from trampling on its roots, as shown by the central image. The workforce access trail through the marsh to the ravine had the highest impact, showing no vegetation after a year of recovery. In conclusion, there was a net environmental benefit for not treating oiled vegetation, marginal benefit for cutting, raking, and removal, and no environmental benefit for using the marsh as an access route to the ravine. The key SCAT consideration here is to reflect upon the operational impacts, in that they could do more harm than the oil itself.
A lot of people can end up just going out with this silt. Silt's going to just pick it up and eat it and take it with it.
The shore segment at the terminal and near the source of the spill was a gravel sediment that became heavily oiled. This is an industrial site, and the ecological values conferred by the shore itself was low. When one sees a heavily oiled shore, one expects to see it being removed by buckets or shovels or machinery. This is a public expectation. Removing oil and oiled sediments is both laborious, but it also creates a lot of oily waste that in turn must be managed. Oily waste generation is very much of a SCAT matter that needs to be addressed and recognized when making cleanup recommendations. In the case of the Westwood Annette bunker spill, oily waste generation was minimized by two similar treatment methods, referred to as wet and dry sediment mixing. An example, wet mixing, is when the oil-saturated gravel sediment is stirred up by raking at the water and shore interface as the tide rises. The heavy oil released is captured by pom-poms, which was disposed as oily waste, but the oily sheen created is captured by fine silt and clay in the water. In this case, the abundance of glacial silt, and left for natural biodegradation over time. Wet mixing using rakes, shovels, and water stingers is a common practice, but is also very contentious. As such, we'll explore this matter further over the next couple slides. When one is working with oiled sediments in place or in situ, or you are relocating it to, say, the surf zone, which is where the water and the shore interface, one is relying on natural recovery or attenuation. Mixing in place or agitating with water pressure hoses, referred to as stingers, and or relocating the oil to the surf zone requires some wave energy. That creates an abrasive action that further removes the oil or polishes the sediment, as well as there requires some clays or silt to bind with the released oil. Both enhance natural biodegradation. As well, there is no oily waste generated. With a bit of a helping hand to rake and break up the oiled sediment, one is then taking advantage of nature's natural wash machine, and that is its wave action at the shore's interface. Mixing oiled sediment in place or relocating to the surf zone can be used to remove heavy saturated oil insofar that the bulk oil is removed by some combination of sorbents being contained and skimmed, leaving the remainder for natural recovery. A second and more common approach is that after heavy oil has been removed, say from a sandy recreational beach, which has a high endpoint assigned as no visible oil, such as a stain, then tilling, raking, digging, or plowing the sand, or relocating it into the surf zone is a form of polishing the beach sand to the point where no visible oil may be seen. The challenge to, say, a SCAT coordinator or leader is to communicate the technical and scientific merits of oiled sediment mixing or relocation, as well as a common practice of flushing heavy oiled sediments with large quantities of water, referred to as flushing and deluge treatments, compared to actual physical removal. It's important not to go down the scientific rabbit hole when explaining to representatives and stakeholders. SCAT also has to understand that science isn't perfect. If too much heavy oil is moved into the water column, there's a potential that it may sink rather than disperse by collecting on the fine silts and sediments. As such, there still is a judgment call of when, where to use such treatment methods that do not manually remove the oil itself. The shore sediment at the terminal and near the source of the oil was a gravel-sand mixture. The heavy oil penetrated into it, creating an asphalt pavement, as shown by the image at the top left. This pavement was agitated and broken up into rows using a bobcat, as shown by the image to the right. Pom-pom sorbents were interspersed to capture any of the heavy oil. It was only then a matter of waiting for several tidal cycles and some wave energy to release and clean the shore. This treatment method is referred to as dry mixing of oil sediment. This is a common practice for recreational beaches, as referred to in the previous slide. Both wet and dry mixing can only be done when there's no ecological resources on the shore, such as embedded in the sediment, such as shellfish, or resting on top, such as kelp. As well, it may not be applicable to a culturally sensitive site. This is why the SCAT team has an archaeologist and a biologist on board. The major environmental impact of the oil spill from the Westwood Annette was actually quite localized around the terminal marsh, as explained. There was, however, oiling up the Howe Sound, as streams of oil from the source drifted with winds and current. As quite common with many oil spills, some of the oil will miss shorelines completely, while others will leave sporadic traces of oil on vegetation and rocks and sediments. These shores still need a SCAT assessment, which is generally done by a rapid survey. The two objectives are to locate and map shores where no oiling occurred, as well as shores in which the oiling is so low that no treatment is actually required. This rapid field assessment or reconnaissance was done for the Westwood Annette bunker spill by small vessel. The documentation of findings was done on a shoreline inspection report that had 3 criteria: no oil found, no further treatment required, or assessment required. However, before going out and doing a rapid SCAT assessment, one had to determine what level oiling would be considered not requiring any form of treatment, based on distribution, amount, and location. This determination is part of the SCAT collaborations with agencies, representatives, and upland users. No treatment was required where there was only trace amounts of oil found on shores and vegetation, as depicted by the images above. Howe Sound is essentially a remote area. Nevertheless, where any kind of traced oil was found within a recreational site, such as in front of a lodge or private accommodation, it was recommended that that oil be removed. This is where 2 of the SCAT innovations can come in play, but was not done for the Westwood Annette spill. The first is to use the canine SCAT, whereby dogs can find trace amounts of oil faster and more thorough than people can running up and down a beach. The second approach is when you find trace amounts of oil is to actually remove it at the time in which you're doing the shoreline inspections. This is referred to as bag and go. It only requires you to take a couple operational personnel along with you while you're doing your SCAT surveys. The third case study is fundamentally different from the previous 2 in that the Queen of the North ferry that sank near Gill Island, British Columbia on March 2006 was carrying marine diesel oil rather than a residual heavy oil spilled from the Prestige oil tanker and the Westwood Annette cargo vessel. As marine diesel is a light fuel product, the SCAT assessment and the actual treatment options taken differed as well. As the Queen of North was traveling south, when it exited Grenville Channel, it failed to make a course correction and struck Gill Island. The impact severely gashed the vessel's bottom hull, releasing its oil, and then it promptly sank. Unfortunately, 2 lives were lost. There was an instantaneous release of oil, then over the next week, a minor seepage from the site of its actual sinking location. The sea conditions were calm and weather was warm with a minor breeze and choppy water. These conditions prompted rapid evaporation of the diesel, but nevertheless, some of it did get to shore. After the ferry struck hard on Gill Island, there was an instantaneous release of oil. From that point on, there was seepage. As marine diesel is light, it's actually quite difficult to recover. There was, however, an attempt by using a V-sweep system as shown by the image below. Winds played a dominant role in the trajectory and spread of the marine diesel, but currents also had a role. It's very important at the onset of any oil spill of any type of oil to know where the leading edge was and the envelope of the entire spill. This information is gathered by aerial observations at a reconnaissance level, usually done by helicopter, or in the case of the Queen of the North, it was done by fixed wing. It was very important in this case to get up and seeing where the oil was going. As being a light oil, it was evaporating very quickly. The image on the bottom right shows that there was wind conditions that were creating windrolls of the oil, which helped determine where the primary direction and impact of the oil was going. Seeing unbanded life jackets on shore also was an indicator of the primary impacted shores. This entire region has a high First Nations or indigenous interest in the way of fishing and harvesting. As a result, it was very important to know where the entire contamination would have affected their livelihood. This important field data becomes part of post-incident monitoring to determine levels of contaminations of shellfish, kelps, and other shoreline resources. Once the marine oil reached shores and islands, it lingered around like any other transitional oil in amongst the crevices and coves and channels and within kelp beds. However, this oil was not recoverable. For the most part, the oil was at the rainbow sheen level. This is at a molecular level of thickness, and within a few days evaporated. The silver lining in this incident was that it was warm, windy, and choppy waters that help evaporate this oil quite quickly. Nevertheless, these factors did not negate the concerns of First Nations about the quality and safety of their harvested food, particularly shellfish. First Nations was therefore very much engaged in the incident management from beginning to end, including the SCAT process, and were very valued contributors because of their local knowledge. Though during the incidents there was nearshore protection booms deployed in critical clam harvesting areas, there was actually no shoreline cleanup undertaken. However, there still was a SCAT rapid field assessment. This assessment was guided by the aerial observations, reconnaissance data, showing where the leading edge was and the envelope of the spill. In the most contaminated shores, largely determined by where abandoned life jackets appeared, there was visible sheens of oil within pooled water and wet sediments. For the less contaminated shores, it was only a matter of scooping up sediments and smelling for oil to determine presence and absence. As simple as it may seem, this was actually very effective. Here's another opportunity where the K9 SCAT dogs could come into play with their much more sensitive smell. As trained in oil sampling, the SCAT team took a lot of oil samples of sediments for analytical lab analyses. Legal and analytical level of oil sampling is a specialized skill on top of that of SCAT.